Hey guys, so today we are going to talk about water quality testing. So why do we care about this? Fresh water is rare and we want to take care of our good resources. And actually most of the fresh water in the world that's could be available is actually not available. It's trapped in glaciers and ice and things like that. So, whatever sources we have, like aquifers and groundwater and rivers and streams and all those things, we need to take good care of it. So, in the US in the 1970s, the Safe Drinking Water Act was passed to just make sure that all the drinking water in the United States is safe. Okay, and today over 90 contaminants are regulated by the Safe Drinking Water Act. So let's talk about some of the different ways that we can test water. Okay, um, first thing is we talked a little bit about this before, but measurements are usually done in ppm or reported in ppm, which is parts per million. So 1 part per million is about 1 milligram per liter, okay, of whatever pollutant we're talking about. So we have 1 part per million. We're usually talking about 1 milligram of that pollutant per liter of water, okay? So if you take 1 divided by a million uh, times 100 for a percentage formula, you get about 0.0001% of what you're drinking has the pollutant if it's 1 ppm, which sounds like an extremely small number, not really something that we should worry about, but even small numbers like that can cause some pretty serious health conditions for human beings and all kinds of problems for animals as well. Okay? So just keep that in mind that it doesn't have to be a big percentage for it to be troublesome. Okay? So remember, 1 ppm is 1 divided by a million. Okay? All right, so what are we measuring when we're testing water? We've talked lots about nutrients, okay? Nitrates, phosphates, also ammonia, because that would be a source of nitrogen. We can test for those things. We can test for the pH of water. Most natural ranges are within 5.5 to 8, okay? For you to know if there's something going on with a certain body of water, you probably need data from before this first time that something is happening, unless you're getting something that's very extremely acidic, very extremely basic. But for just normal ranges, you need some sort of historic data usually to compare. Alkalinity. So alkalinity just means basic, like not acidic, okay? But usually alkalinity is also measured in ppm, and really all we're measuring there is calcium carbonate, okay? Which is something that we are going to learn more about eventually. It's important for coral reefs, but basically those calcium carbonate ions there will help to like buffer or keep the pH within a certain range, okay? All right. We can also measure the salinity of water, so how much salt is in the water. Okay. So this is particularly important for groundwater if an aquifer is near the ocean. Okay, because so here is an aquifer near the ocean. So you have the land surface. Water table is just the area underground that's completely saturated with water. And you have fresh groundwater. Of course, you have the ocean, so you're going to have some saline groundwater. And then you're going to have a zone of transition where the salinity decreases. Okay, so the ocean water is about 3% salt water. So this here is going to be close to 3% salt water. And then that's going to decrease for a certain range until you get the fresh water that's underneath the groundwater. Well, if you've got a well and you're constantly pumping that fresh water, what's going to happen is something called salt intrusion. That saline water is going to move into where that fresh water has been removed. Okay, so that is a problem, especially if you are using an aquifer that's close to the coast. And if you think about the state of Florida, how it's surrounded by salt water on all three sides, it can be a really significant issue there. Chloride ion testing is an indirect way to measure for salinity. So remember, table salt is NaCl. So if you've got lots of chloride ions in your water, you may just have too much salt in your water. Okay, So that's a way to test for that. Turbidity just means it's the total suspended solids, the TSS. It measures how clear your water is. Okay, so if you have high turbidity, that means your water is cloudy. So there's good and bads about this. You just have to know what that body of water that you're testing is supposed to be like. Okay, if the water is too cloudy, it can affect sunlight penetration, which will decrease photosynthesis for that particular area. Okay, and of course that will affect the ecosystem. Obviously, the aesthetics of the body of water. Okay, people don't usually like to swim or to have fun in cloudy water. So there's the cultural significance there. On the other hand, cloudy water is typically warmed more easily than clear water. So because the suspended solids will absorb sunlight. So it really depends on what the body of water can be like, okay? But that's something that you can measure as well. You can measure turbidity. Microorganisms. So typically something that we don't think here in the US because we have good regulations is coliform bacteria. Okay, so these are bacteria that live in all of our guts and all of mammals' guts, but they come out in the feces, human feces, mammal feces. So if you are having sewage dumped in a body of water, which can be a significant issue in a lot of developing countries, you can have coliform bacteria, and you can get all kinds of diseases if people are drinking water with this bacteria in it. Okay, so according to the US EPA, there can be no coliform bacteria at all if a water will be drunk, if a source of water is going to be for drinking water. But they will allow a small amount for swimming. So I don't know how you feel about that, but that doesn't sound good to me. And of course, we test for E. coli because E. coli can also be a source of disease. All right, let's keep going. Dissolved oxygen. You can test for the dissolved oxygen in water, which is an indirect way to measure for BOD. Okay, and then also heavy metals. So if you look at a periodic table, your heavy metals tend to be in the center or towards the bottom. Okay, it's not true of all of them, but a lot of them. So like chromium, cadmium, lead, tin, those are not good metals that we want to have in our system. Okay, so maybe look at a periodic table and locate them real quick, just so you can be familiar with them. Necessary metals for humans in trace amounts are things like zinc, iron, calcium, magnesium, potassium, sodium. These are things that we need in trace amounts. Of course, too much of some of these can also cause problems. Okay. All right, so macroinvertebrates. So certain species have low tolerance for pollution. Okay, so if you keep track of the population of these organisms in bodies of water, it's a really effective way to measure water quality. Okay, because these organisms are in the water all the time. I can go in today and measure, the DO and the pH and the whatever water, and come back a week later, but then I don't have any measurements for any of that time in between. But those organisms, they were in that water all the time. And if it's not safe for them, they're going to go downstream somewhere else. Okay, so macroinvertebrates that are sensitive to pollution they're good indicator species, okay, to measure the quality of water. And that's all we've got.